Hello and welcome to the front side of homework number 7. I'm sure everyone's super excited. Thanks for watching the video. Thank you for doing your homework. You are all wonderful people. So without further ado, let's get started. So looking at this first part, thinking back to class last week, which I know is a while ago, we talked about discrete and continuous data. So just as a reminder, discrete data means that it's in like distinct categories. So like if we're talking about making a basketball shot or throwing paper into a bag, it's like you can't throw it a half a time, right? So we know that something like that would be discrete. Continuous would be something like height or time, where you can have little markers between. So like you can talk about minutes, you can talk about hours, you can talk about seconds, milliseconds, and so on and so forth. So something like that would be continuous, because you're never going to have two times, or very rarely, where they'll be exactly the same. So looking at these examples, so speeds of cars traveling along a road. So speed is one of those things that has to deal with time, right? So we have a speed of a car. Normally we would say something like 65, 64, but that would be an example of continuous data, right? Because someone could be going 65.2345 seconds, or meters per second, or miles per second, or whatever we want our speed to be. Or they could be going 64.2221, right? Like it's never gonna be exactly the same. And once again, speed, like time, is going to be a continuous set of data. So numbers of members in a family. So that would be considered discrete, because in your family, you're never going to have half a person, right? You could have something like half siblings, but they're still a full member of your family, right? So that would be an example of discrete, because it's a counting number, so you can physically count members of your family. Maximum daily temperatures, that's actually a really interesting one too. Temperature, remember, could be, we normally say it in whole degrees, but it could be any number of decimal points of a degree, right? So it's very rare that it'll be the exact same temperature on any given day. So that's something that we would think about as being continuous as well, because temperature, you can have temperatures at different decimal points, right? So it's not like you can just count them. There's measures in between. So heights of people in class measured to the nearest centimeter. So this one's actually pretty tricky. I was talking to Miss Avery about this one, and we decided that this one should be discrete or continuous, and I'll explain why as soon as I finish writing. So heights of people in a class measured to the nearest centimeter. So in that way, because it says to the nearest centimeter, that could potentially be considered discrete, right? Because we have a finite number of choices, or only a certain number of heights that it could be, because it would be heights and like heights to the nearest centimeter. So there wouldn't be anything in between. However, we do talk about how heights are often continuous. So in that respect, they kind of would be, right? Because there's a lot of all the heights with all the different centimeter combination, there's a lot going on. So long story short, it kind of could be considered either. I think it would probably lean more towards discrete, just because we only have a set number we can choose from, because we're always rounding to the nearest centimeter. But there's enough where it could kind of be considered continuous too. So we're going to leave that off with discrete or continuous. Last one is daily intake of protein by members of a sporting team. I think that one would be continuous as well, because we don't know what like measure for intake. I would say probably grams, right? That's how we normally talk about how much protein we consume. Well, you can have 1 gram, you can have 1.5 grams, you can have 1.3725 grams. So I think something like that would be considered continuous, because there's so, like, you could have from 0 to however many grams you would normally eat in a day. I honestly don't know what that would be, but you have the run of the whole continuum. It's not something you can just count. That's discrete. Good. So moving on to this one. If you disagree with any of those and have an argument for a different way, that's totally fine. It can be really hard to tell sometimes between discrete and continuous. So if you want to fight me or come argue with me about one of these terms, that is totally welcome, and you can ask me and Miss Avra a question, me or Miss Avra rather, a question anytime you have one about something like that. Moving on, we have this next one. So 200 people were asked the amount of time, T, in minutes that they had spent in the supermarket. So the results are represented in the table below. So here, this is actually something that we're going to do in class tomorrow. Looking at this table, we have time up here. If the time falls between 0 and 10 minutes, it goes in this column, 10 and 20, 20 and 30, so on and so forth. And this is the number of people who said they spent that much time in the supermarket. We see that the most is between 20 and 30 minutes. That seems pretty accurate based on when I go to the supermarket, but you know, we don't care about that right now. So state if the data is discrete or continuous and why. So we're looking at this data, whether it's discrete or continuous. So there's two reasons why I think this is continuous. So I'm going to write that it's continuous. Reason number one is because time is continuous, right? Like you could have someone who's in there for minutes, hours, seconds, milliseconds. No two people are going to be in there for exactly the same amount of time. So we know that time is continuous. So that's what I'm going to say. So continuous because time is continuous. And the second reason is also, I'm not going to write this down as a reason, but looking at these, you see how it's 0 is less than t is less than or equal to 10. The next one says 10 is less than t is less than or equal to 20. So anywhere from 0 to 50, nowhere in there is there a number that's not included or is there a break. So looking at this, you can see that even if it was 1 second or 1.5 seconds or 1.56 seconds, it will still all fit in that category. And that's another reason why I know it's continuous is just by the way that it's written. So if you weren't sure, looking at something like this where you see it's always less than or equal to, less than or equal to, that's another really good way to check to see if your data is going to be continuous. Good, so let's move on to the next one, which is very similar to the last one. So a survey of the number of bedrooms in a survey was conducted of the number of bedrooms in 208 randomly chosen houses. So the results are shown here. We have numbers of bedrooms, number of houses. State if the data is discrete or continuous and why. So this is a case where it's actually pretty clear cut, which is nice. This data is going to be discrete because we only can have a certain number of bedrooms each time. Like you can't really have a half a bedroom, right? So you either have 1, 2, 3, 4, 5, or 6 bedrooms in this model. So if I was going to explain why, I would say number of bedrooms can be counted, which is basically a way of saying it can only be whole numbers. So can be counted, only whole positive numbers, right? Can't have a negative bedroom. Good. So that's my heuristic for how to know if something's discrete, if I can count them, and I can physically count the number of bedrooms. Good, and so there aren't any ACT problems on this homework, so this is actually, we're done with the front side video. So if you watched this, thank you for watching. If you have any questions, as always, come see me or Miss Avra.